So here's the Unit 7 review for 8th grade. We'll go ahead and take a look at number 1, which unfortunately has no answer choices for us, so we are going to end up making up our own. So on number 1, it says triangle LMN and triangle L prime, M prime, N prime are similar triangles. Which proportion must be true? They only give us a few numbers to work with on this. And I know usually what we end up doing is we solve for x. So I know it's kind of hard to see, but right here is x, okay? So I'm going to highlight this side because that's going to be our x side. Well, on the other side, it matches that 4.68. So those two sides match. Now, I get to kind of pick. It doesn't really matter which one I go with. I'm going to go with the side that has the numbers already. So, because this has 3.24 here, so I've got to use the 5.4 here, okay? So whenever I set up my proportion, I like to do line equals line. I always start with whatever x is first. You don't necessarily have to. There are a lot of different ways to do this, but I want to solve for x first. And I call this triangle 1, triangle 2. Well, I always do triangle 1 on the for the left side fraction. So I've got x and 5.4, okay? Over on the right side, and I know all of you guys are looking around right now, that was the tardy bell while I'm recording this. You are not actually supposed to leave yet, at least it's not likely. Anyways, on the right side, we're going to call it triangle 2. Well, I did x on top, so I've got to do 4.68 on top for this one. And then on the bottom, it's got to be the same triangle, so it's going to be 3.24. I know, again, it just wants to know which proportion is true, but for this time around, we're just going to solve for x. What I highly recommend doing is just doing cross multiply, divide. So cross multiply, divide by the limit guy, so you do 5.4 times 4.68, and that comes out to 25. Let's see, let me write this down, 25.272. Once you have that, you divide by 3.24. And whenever you divide those, you end up getting 7.8. So again, I know this one was supposed to be looking for a proportion. Since it didn't have it, decided to solve for it instead. So we'll say 7.8 here. Hey, look, answer's A. So now we'll move on to number 2. So number 2 says the quadrilateral RST and its dilation quadrilateral QRST, or primes, whatever, are shown below. Which statement about quadrilateral QSRT and quadrilateral, the prime version, is true? Okay, so we'll read through these first and see what to do from there. So it says, A says the side lengths of quadrilateral prime are 1/2 the side lengths of quadrilateral QSRT. And actually, if I go through all these, it looks like we need to go ahead and work it out for ourselves, and then we can go through and read it. So taking a look, the primes right here, if you can see the little mark above it, that means that this is the new one, okay? This is the old one. So to find out what our scale factor is going to be, scale factor is new divided by old. The best way to do that on a figure is to get some points. I like sticking with simple ones. So we'll use R, since I haven't covered this one up. So R looks like that is over 8 and up 2. And then R prime is going to be over 4 and up 1. Well, without looking too hard at it, I mean, new divided by old, there's, again, prime, that thing, is the new one. So I'm doing 4 divided by 8. Or I can do 1 divided by 2. Either way, they're a half. So we know our scale factor is going to be 1/2. So I'm going to write that over here. Scale factor is 1/2. But now we're going to go through and read these, okay? So we can figure out which one matches. So I know we already read A. So it says the prime version is half the side length. Well, that's what we just found out. This one says twice. The reason, if you divided it backwards, you would have gotten twice. So they're ready for you to mess that up. So make sure you do new divided by old every time. And then C and D, they start talking about the angles. Well, angles, they always have to be the exact same. Hopefully I get a chance to show you in class that those are the exact same. I've got a quick little proof for it. But for now, take my word at it. Angles are all the exact same. And D, again, it talks about the angles, and angles have to be the exact same. They will never be 2 times greater. That's got to be out. Answer is A on number 2. Mine is on separate pages, so I'm going to have to skip over to a page for number 3. So it says the graphic below shows triangle ABC and its dilation, triangle prime, with the origin as the center of dilation, which it always is for us. The scale factor is 2. The actual question is, it says which statement about both triangles is true. And again, I just want to mention that the primes, I'm going to do this in the correct color this time, that has the prime next to it. So that's the new one. This is the old one. We are always going to do new divided by old for our scale factor. I don't even know if we need that yet, but I'm just writing it down just so we're a little consistent on it. But again, we're just trying to figure out what's true. So A says the corresponding angles of triangle ABC and the prime version are not congruent. They are always congruent. That is not true. The corresponding sides of triangle ABC and triangle ABC, blah, 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 are congruent. Well, the sides, one's bigger than the other. The sizes can't be congruent. And just as a quick reminder, congruent means the exact same. B is out. And C, corresponding angles of triangle ABC and triangle prime, whatever, are congruent. That's what we've been saying. These angles, like for C and C prime, they have to be the exact same. And just to double check, D says triangle ABC is congruent to triangle ABC prime. That's not true, because clearly they are different sizes. D is also out. All right, from here we'll move on to number 4. This one's got a bit of a typo on it. This is our algebraic representation. We're going to change this to 1/3 x, 1/3 y. That just goes in that spot where I just kind of marked it out, okay? So the coordinates of the vertices of rectangle PQR have vertices, and it gives you the coordinates right here. You can go through and read all those if you feel like it. And then what we're supposed to be doing, it's going to be dilated by this scale factor here that we just came up with, okay? So our scale factor is 1/3. So what you do, whenever you have a scale factor, you multiply it times your original to get to your new one, okay? So what I'm going to do is, I'm only going to do this with 1 point, because usually 1 point's enough. They told me that P is -3 and 3. So what I'm going to do is I'm going to take my x, and I'm going to multiply it times this x. Then I'm going to take my y, I'm going to multiply it times this y. So 1/3 times 3 for P prime is going to be -1. 1/3 times 3 is just going to be +1. So I'm looking for an answer choice that has a P prime of -1, 1. My answer choice is B. And if I go through and check all those other ones, it would all work out. The actual question wants us to find the algebraic representation, and unfortunately on this version there aren't any answer choices, so we're going to start with, we're going to use C and C prime. We're going to use those 2 points. So C, the coordinates are going to be 2, +1. C prime is going to be 4, +2. So again, the prime is the new one, so we do new divided by old, or I could have done new divided by old, okay? Just to kind of clarify that these numbers right here are the ones that I was using, and then these numbers here are the ones that I was using. Either way, I'm going to get a scale factor of 2. So if my scale factor is 2, my algebraic representation will look like this. XY, from my original points, are going to be changed by doing 2x and 2y. So number 6, it says triangle ABC is graphed on the coordinate plane as shown below. It says if triangle ABC is rotated 270 degrees clockwise about the origin, which of the following statements would be true? We don't actually have to work anything out on this one. We just got to go with what we know. So A, it says they will both have the same orientation. Well, if I'm rotating it, they will not have the same orientation. On B, it says they will not be congruent. Well, if I rotate it, I'm not really changing the shape or the size. They actually will be congruent. And C, it says triangle ABC and the prime will not have the same orientation. Well, we just said that on A, that if I rotate it, they're not going to have the same orientation. My answer choice is going to be C on this one. And then D, just to double check, it says they will have the same orientation and they will be congruent. Well, if I'm rotating it, again, they will not have the same orientation, so D was out. On to number 7. On this one, they give us PQRS as our rectangle, and they want to know what scale factor we can apply to create a congruent rectangle. Well, the only way to create something that's the exact same shape and the exact same size is a scale factor of 1. On number 8, they give us a triangle and a quadrant and says which transformation would create a new triangle that is not congruent to the original. The only type of transformation that creates a new version that's not congruent, like not same shape, not same size, is going to be a dilation. And I know this doesn't have the rest of the numbers on there. It could be 2, it could be 5, it could be 1,000,000. Took longer to write 1,000,000 than I realized. Either way, whatever my scale factor is, it's not going to be the same size unless it's a scale factor of 1. That's the only case where it would be congruent. Now for number 9, it says correctly organize the following transformations into those that always preserve congruence and those that may not always preserve congruence. Well, fortunately, they are already in that order. So reflections, rotations, and translations, they stay the exact same shape, the exact same size. Sometimes they just change directions. Dilations, well, it may not always preserve congruence. In fact, it very rarely does unless it's 1 like we talked about before. Now moving on to number 10. On this one, we're supposed to be taking a rectangle and we're supposed to be translating it. Well, translating is just moving it from side to side or up and down or whatever else. So here it says 6 units down. Down is the y-axis, so I do y minus 6. 4 units to the right, well, that would be x, and then to the right is positive, so x plus 4. Whenever we do translations, we do them in alphabetical order. So I would do x plus 4, and I would do y minus 6. The only one that matches is D. Number 11 is just a memorization problem. What they do is they're talking about transforming this quadrilateral, and they give us all these new coordinates. Well, that's the type of transformation we're going to be doing. And so you're just going to have to know that if you see this transformation right here, x negative y, that's going to be a reflection across the x-axis. 12 is kind of the same thing. We're doing a rotation of 270 degrees, and they say our points are A, B. Well, if I'm rotating 270 degrees, first I know that they are going to swap places, and then I'm going to change the sign on the second one. Well, answer choice ends up being A. Again, that's just memorization. There's nothing to really do to figure that one out. 13 is a little bit tough because we're talking about the relationship between the areas of the two rectangles. Unfortunately, we can't just multiply the sides to get the areas because on the smaller triangle, we're missing a side. First thing that we have to do is we have to do new divided by old. So I'm going to take that side of 3 and divide it by 9, and I get a scale factor of 1/3. So what I'm going to do is I'm going to take that scale factor of 1/3 and multiply it times this 3.6 in order to get my missing side. Whenever I do that, x ends up being 1.2. Now I can use my areas. So to find the area of the larger triangle, I'm going to do 3.6 times 9. So this area ends up being 32.4. And on the other side, I'm going to do 1.2 times 3 to find the area of 3.6. Okay? So in order to do that, what I've got to do, in order to find my actual relationship, I've got to do 3.6, or my new one, so I'll do 3.6 divided by the area of my old one, 32.4. And whenever I do that, I end up getting, well, 0.1 repeating, which is 1/9. So with a scale factor of 1/9, we're going to go with A on this one because it's not on my copy. It says the area of the rectangle of ABC is 1/9 the area of rectangle WXYZ. So number 14 says if Sebastian increases the length and width of the pool by a scale factor of 3, what will be the resulting effect on the perimeter of the new pool? Well, whenever you're talking about scale factors and perimeter, this only works for perimeter, not for area. If you're doing a scale factor of 3, well, the perimeter will also be 3 times the perimeter of the original. So answer is B on number 14. So number 15, I've already drawn out the triangles ABC and XYZ. As you can see on AB and AC, they're the same number. So it has to be the same thing over here. Those have to be the same number. But first we got to get a scale factor. This is our new one here. This is our old one here. So we do new divided by old. So we would do 10 divided by 8 to get our scale factor. Whenever you do 10 divided by 8, you end up getting 1.25. And so if you look at answer choice B, it says XY, this right here, and XZ, that right there, are the same, which is what we already talked about. And they're going to be 18.75 centimeters because the scale factor for dilating triangle ABC is 1.25, which is what we just found out here. I need to double check the 18.75, so what I would do is I'd do 1.25, and I'd multiply that by 15, and that does come out to 18.75. On number 16, we've got triangle ABC, and we're going to dilate it to create the prime version. So it says which statement is not true. Watch out for not statements, they drive me crazy. So A says for a dilation of a scale factor of 3, the orientation of the vertices will be the same. Orientation does not change on dilation, so that is a true statement. Answer choice B says for a dilation with a scale factor of 0.7, the orientation of the figures will be the same. Yeah, that's the exact same. We're looking for a not true statement. On C says for a dilation of a scale factor of 2, corresponding sides ABC and the prime version will be congruent. Well, the sides will not be congruent. They'll be proportional but not congruent. That is not a true statement, and that's what we're looking for. Final one, number 17. So we're transforming these two figures, and it wants to know which statement about these triangles is true. They're not triangles, but whatever. If you look here, all of these sides are like the exact same distance from each other. So it looks like it's been reflected over this y-axis right here. Well, the only one that talks about a reflection over the y-axis are B and D. But the big difference is this one on B, it says corresponding sides and corresponding angles. So the angles and the sides are congruent. They're the exact same. Nothing's changed about these after the reflection. So your answer ends up being B on this one.